AMC question because there are not too much tedious calculations involved in AMC problems generally. And in this year, there are only 3 questions which are mainly numerical or algebraic calculations. And each of them have some tricks which can make the calculation quicker. And the first question is question 3. This question asks us to compare the 3 different fractions to see which one is smallest, which one is the largest. And if you observe these 3 fractions, what you will find? You will find that the numerators are always greater than the denominators. What are these kind of fractions called? They're called improper fractions. So when I learn this type of fractions in Chinese, translating into English, it means fake fractions, bad fractions, in other words. So how we make bad fractions good fractions? So given that the numerator is greater than the denominator, it means what? All these fractions are greater than 1. So we can deduct 1 from each of them, and that of course will now change the order of these fractions, but can help us see these fractions clearly. So deduct 1 from the first one. 15 minus 11 is 4, so 4 over 11. And then deduct 1 from the second fraction. 19 minus 15, 4, 4 over 15. And then 17 minus 13 is also 4, so 4 over 13. So after we deduct 1 from all the fractions, we get 3 fractions which happen to have the same numerator but different denominators. So we know that when we do a division, the larger divisor we have, the smaller quotient we have. So for these fractions, it's easy to order that which one is the smallest? 4 over 15. And which one is the next? It will be 4 over 13, and the largest one is 4 over 11. And then we can select the answer. The answer would be just the one that the denominator have this order, 15, 13, and 11. So E is the correct answer. So we solved question 3. Hopefully you do it also within a minute. The question is question 17. This question is to calculate the product of many complicated fractions. And for things like that, which not all the fractions can be listed, there are dots in the middle, and you know what would be the typical method, or what would be the typical structure in order to do this calculation. That method is called what? It's called telescoping. So normally we should have some cancellation between adjacent terms so that in the end we only have a few terms at the start and a few terms in the end. So then we just finally do a standard calculation. So that is the way how we solve such questions. And also from a simple observation, if you just look at the first numbers in these products, for example, you look at the denominator of the second fraction. You have 3 times 3. And then for the numerator of the first fraction and the numerator of the third fraction, they all have 3. So it's kind of like cancel out. So from this simple observation, you could have the rough idea. Okay, so most of the middle ones will probably be canceled out. But the challenge is we have to do the cancellation in a very systematic way. So the clever way I think of is I will write down both the numerator and the denominator not in one single line but in 2 lines, as each denominator and each numerator now is a small product. So this product is numerator divided by denominator. So for numerator, in the first line I will write down the first factors in each denominator because they form consecutive integers. So 1 times 2 times 3, dot, dot, dot. The last one we know would be, the second to the last one is 97 and then 98. And then for the second line, we write down the second factor in all the numerators. So it will be 2 times 3 times dot, 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 times 98 and times 99. Okay, that's how I write. Of course, there's also a product of these two lines. So that's how I write the numerator. Then for the denominator, I apply the same. The denominator is actually simple because each denominator is a square. So I just write 2 times 3 times dot, 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 times what? 98 and 99. And then the next line would be the same. 2.3 times 98 times 99. Of course, these two lines will also multiply together. And now I can do cancellation. So how to cancel out? Let's compare the first line here with the first line here. What is the common point? The common part would be this, right? Because here it's starting from 2, 3 up to 98. Here it is 2, 3 up to 98. Okay, so these two parts cancel out. Then we compare the second line in the numerator versus the second line in the denominator. Oh, you see, that is actually great. Did I miss anything? Oh, I missed something here. That would be starting with 3, 4 up to 99 and 100. Sorry, I made a mistake. So it would be 3 times 4 times 99 times 100. Okay, you compare these two lines, what you find? You find from 3 to 99, that is the common part in the second line. So you can cancel out. Okay, so after we cancel out this common part, what's left? What's left is very simple. There's only 1 times 100 left on top, 2 times 99 left on the bottom. These 2 and 100 can be cancelled, common factor 5. So the final result would be 50 over 99. So as long as you write things in an organized way, this question becomes a piece of cake. Calculation question is question 20, which again is a new topic starting from this year's AMC 8, which is quadratic equation. But this quadratic equation actually is not that hard. Yes, rigorously speaking, it's not really a quadratic equation, given that it has x squared and then minus 5 then square. But essentially, it's just to solve a quadratic equation, to state things rigorously. And for this question, it's actually not hard, but we need to be careful. The careful thing is don't forget the negative numbers. So from the format of this equation, so it is, let's just close your eyes, just forget about x squared minus 5, just think it's something. So something squared is what? Is 16. Which square can be 16? Of course, 4 squared is 16. But remember, there's another possibility, which is, given that 4 squared is 16, so negative 4 squared is also 16. So from that one, that equation, what we should get is x squared minus 5 is either positive 4 or x squared minus 5 is negative 4. Okay, so if x squared minus 5 is 4, of course x squared would be 9. And in this case, x squared would be, you move this negative 5 from left side to right side, you need to change the sign. So 5 minus 4. So x squared equals 1. Okay, now we have two equations. For these two equations, what would be the solution? Again, don't forget the negative numbers. X squared equals 9, so x could be plus 3 and minus 3. X squared equals 1, x could be plus 1 and then minus 1. Now altogether, how many solutions we have? 1, 2, 3, 4. So we solve this question 20. As long as you don't forget the negative numbers, you should be able to get the correct answer.